Okay, so should I repeat from the top? You guys can see the screen. I'm going to shrink it a bit. So let's say I study a variable like stock returns, and the stock is stock X, and I observe it for a long period of time. I see that the returns, the dollar returns, like, so for every dollar invested, what am I making on holding that stock? And I observe it for a long period of time, or I don't hold it. I'm observing what people are getting, okay? Because I'm not convinced. So I'm going to observe it, going to see its distribution, make a histogram, see the mean, see if it's stable, see the standard deviation over a period of time, and then record that information. And at the same time, I'm observing stock Y and how people holding it, what their returns are. I see their mean, I see their standard deviation, I see it's basically a normal distribution. And then I decide to buy both of them. And should I have to wait observing the returns of people who hold both securities over time before I decide to purchase them in a portfolio? Well, no, because the expected value, well, let's talk about that. The expected value of the sum of the two is the same as the sum of their expected values. In other words, the average of the sum of two variables is the sum of their averages. Similarly, the average of the difference of two variables is the sum of their difference, okay? So this is a rule, and it's been established and studied. Distributions have been observed to see that this is in fact empirically correct. And you could even show it with different distributions that is fact correct. Doesn't have to be a normal distribution. That's in fact how it works, okay? Okay, so let's go back to that problem. Where's that? Oh, let's go back to number 2. So what do you see here? What is the new average? What would you say? Let's talk about the average. So are we talking about the sum of two variables here? What are they doing to the variable? So the variable is, this one, like the returns, basically, the expected value, not the expected value, this is discrete distribution. So you have these possible outcomes and this distribution. You could actually calculate the mean of this, okay? How would you calculate the mean of this distribution?
You add them up first.
The value plus the weight, the probability.
Okay, so for this kind of a distribution, yeah, for this, so this is different than you getting data. This is not data. This is the distribution. So what does that mean? It means that you have like a frequency distribution, but it's called a discrete distribution. This is the outcome, this is the probability. And we did this. You have to get the weighted average, okay? So the average here is the weighted average, and that's where the 130 comes from. Uh-oh, there's an alarm going. It's okay. So the average is the weighted average. So you can prove to yourself that you get 130. So you multiply these plus the multiple of these plus the multiple of these. Does anybody want me to do that? No? And you need to speak up because, let's see. I get some requests in the chat. Nobody wants me to do that? Okay, so that's the weighted average to get 130. And then you do the same, you have to do the weighted standard deviation as we discussed, or I'm trying to remember if I showed you, we demonstrated that one class. And, or it's in the videos. Now it's saying, take this variable and its probability distribution, and for all 4 possible outcomes, you're going to subtract $1 and double it. What would be the new average? So it's not 2 variables, right? It's 1 variable. So let's go back to the notes and see how I can answer this question. So I started with talking about the sum of 2 variables. Now, where are we going to talk about adding something and doubling? Where is that? Okay, so that was the sum of 2 variables, or and the difference. That's called the linear transformation. When I multiply something to a variable and I add something else, that's called a linear transformation. Multiply. So what if I multiplied x by a number bigger than 1? What would happen to x? So let me get my iPad out. I did this sort of a problem when I talked about the derivation of the standard normal. I'm gonna not do it that way. I'm gonna So my question was, if I take a variable and so let's say so this is a discrete distribution, but we can think about it. We're going to get the rules. I want to describe what I'm talking about, and then we can apply the rule to this discrete distribution. So let's talk about if I had a distribution that looks like this. So this is like roughly symmetric. I don't know if it's normal, but it's symmetric. And this is x. I'm putting it over here because I want to do something with it. So let's say I take x and I multiply every value of x by 2. What happens to the distribution? I say it's symmetric, just so for visual purposes. What happens to the 0 if I multiply 0 by 2? What does it become?
It will be still 0.
Yeah, it'll still be 0. What if I take 1 and I multiply it by 2? What does it become?
2. So your distribution will spread out.
Yeah. And then -1. What if I multiply -1 by 2?
-2.
Yeah. So you can get the idea that it's going to flatten, right? It's going to go like it's more spread out. So it spreads out. I'm doing a bad job today with my drawings. It's just flatter. Okay, good. So what if I multiply by a number less than 1, what's going to happen to it? So I'm going to make x over half.
Gonna become more narrow.
Right. So, so 0, and now it's going to be, if I multiply by 1/2, 1 will become 1/2, and -1 will become -1/2, and it's going to be, like this, right? Like more narrow, tighter. Okay. Everybody's got that? That's what it does, okay? So then, does that affect the mean?
No,
No.
So multiplication does not affect the
No.
mean. Good. So multiplication then, what does it affect? It affects something.
Spread,
Yeah, what do we call that?
variance, or standard
Standard
deviation.
deviation, excellent. So a multiple, or we call it like a scalar or a constant multiple. So a scalar affects the standard deviation. Well, I'll move that over because I want to do something on this other side. Let's do something on the other. So note a scalar. Okay, that's too fancy of a word, but okay. It's not a constant, it's a number that you multiply. That's why they call it a scalar. So I'm going to just say it in words, multiplying right? So multiplying x by a value affects the variance or the standard deviation. We see that below. What if instead I subtract or add a value? Let's subtract a value. So instead I'm going to do x minus 10. What happens to the distribution? I'm going to take every single value of the distribution and minus 10. So what happens to 0? Oh, sorry. What happens to 0?
Remains unaffected.
If I minus 10 from it?
It changes to -10.
Exactly. I basically have the same shape, but all these numbers change. Right? I have the same shape. Well, but 0 becomes -10.
Mhm.
1 becomes
-10, yes.
1 becomes -9.
9.
-1 becomes -11. So it's the same shape. If I take
Okay.
x minus 10, it's the same shape, but it shifts. So it's basically, I moved it, it shifts over. So what does it do to the mean? What happened to the mean?
Yeah, it moved.
Okay, so now let's make a general statement, okay? So whatever you do to each value of the distribution, you also do it to the mean. You notice? You took every value, I mean, I just did a few, but in general, you took every value and subtracted it by 10. So what happened to the mean? It also got subtracted by 10. So whatever you do to every value, you also do to the mean. That's called a shift. It shifts. This is really important because it saves everybody a lot of time. I hope my writing is okay. I'm in a weird. Should I make it clearer or can you understand?
We can understand.
Sorry. I'm gonna try this one a little clearer. I'm like not comfortable where I'm sitting. Okay. All right, so now let's do it over here. We did the scalar multiple, which flattens or narrows, but now let's do the -10. And what's going to happen? Now you guys got the hang of this. So the flattening is done by the multiplication, but the shifting is done by the addition or subtraction. Now I keep subtracting. I'm going to add to the other one. Okay, so let's subtract 2 from this. And so the values become -2, 0 just shifts over. And -4. Okay, so let's add, if we added to the last one here, if we added 2, it would shift forward that way, right? So it will be the same thing. Move this out of the way. But the numbers would change here. So if I add 2, then it's going to be 2, 2.5, and -1. No, sorry, +1.5. Okay. So you guys got the hang of it? You can see this now? And we're going to do the same thing, but now not with the continuous distribution, back to the distribution, the discrete distribution. So whatever I do to every value, I also do to the mean. So what will the mean be here of the new distribution? So let me see the problem again. The casino's average winnings. Let's see if I can. Okay, you're just watching my thing there. Okay. Suppose, okay, so they just, I think it's doubling the prize and then subtracting 1. So doubling the prize and then subtracting 1. And we were already told that the mean, so the mean here was given, well, you could calculate it as $1.30. And they told you that the standard deviation they calculated, and you can do it yourself too. The standard deviation was $3.23. So the new mean would be what? You can call this, if you want to use the symbols, mu x, and this is standard deviation of x. So I have to take the mean, I have to multiply it by 2 and subtract 1. So that's going to be, so actually, is that confusing? If I do, let me do it like this. So I'm gonna call that's gonna be called X. And Y is the new one, which is 2X minus 1.
Let's see. 1.6.
Do you see what I'm doing step by step? So that's going to be, you guys see that 1.6? So that's 2.6 minus 1. Is that the right answer? No,
Yes.
it is. No, it says point. I think you have to double the prize, subtract 1 and then double it. Maybe that's what they mean. Let's try that. Because that's not an option, is it? 1.6. 0.6 is there. So maybe I read it wrong. So Y is minus 1 times 2. You guys with me? You're so quiet. I'm not reading the chat. I need to read the chat.
We are very attentive.
Oh, okay. So then this would be 2. Whatever, again, whatever I do to the X, I do to the mean. So it fits right in there. So that's 2. And then it's 130 minus 1. There you go. So that's really what I meant. I thought it was bad English, but that's really what I wanted you to do. I wrote these questions a long time ago. Okay, so this is, because it says, subtract 1, but however, double the prize. So subtract 1 and then double. So you see that's going to be 0.6?
Yeah.
Okay, now let's talk about the standard deviation. So what did we learn about the standard deviation? Whatever you do to X, it doesn't affect the mean. It didn't shift anywhere. It just affected the spread. So if you multiply, in other words, if you multiply the variable by a value, it affects the standard deviation. It doesn't affect the mean, but it affects the standard deviation. Or it does affect it in that sense, like whatever you do to the mean, you do to the standard deviation. I mean, to that new mean. Okay, so let's see. What am I saying? What am I talking about? I'm saying that sigma y is going to be sigma x how do I explain that? So basically the best way, let me take a step back. I'm going to erase this to avoid confusion. So this was wrong interpretation of the question. And I figured that out. All right, so if I take this y equals 2x minus 1, and I'm just going to write it like that. Is that okay with everybody? Because that's mathematically what it is. It's the same thing.
That's okay.
Then what happens is when I put the variance, this is how I would write it. If I put the variance operator, just like the E, like here I would have done, I didn't do it, but EY is the same as, I'm going to put this in the center now. EY is E of 2x minus 1. And then do the same thing, expand it. So whatever I do to the x, I do to the mean. So this becomes 2 mu x plus 2. That's how the operator works. It just repeats itself, but it changes the x into the mu of x. So the operator variance is going to go on to, like, we're doing all this so we avoid empirical, doing this empirically. We're doing it by theory, introducing this operator. Now, when I use the variance, it doesn't just copy and change this. Anything subtracted or added is just ignored. This turns into variance to x. So that gets dropped out. We know that there's no shift effect. Okay. And then what happens? What do we remember about variance? What's the variance formula? Or what's like, ultimately we talk about the standard deviation because the standard deviation is returning to the units of the variable, right? But when we calculate the variance first, we square our deviations from the mean, remember?
Yes.
So let's just talk about that for a second. If I calculate Sx, it's equal to the square root of right, x minus x bar squared, and then that average. I have that little minus 1 on the bottom there. I can also write that like this, and now it's the variance. So the average of the squared deviations from the mean. Everybody's okay with that?
Yep.
I could also write that as variance of x. This is some of the notations that I use that are all the same thing. I'll put it up here. Everybody's okay with that? So all I did was squared it because this is the same thing and like that. So what if I took every value of x and I multiplied it by 2? What would happen? So every value would be multiplied by 2. And then the rule is whatever I do to every value, I also do to the mean, right? So then the mean would be multiplied by 2. It would look like that. Now looking at this, how can I make this look like the original var x or this? Can I factor out the 2 here to get this back? It's because I want to see the relationship between this one, the var x, and the var 2x. Can I do that? Is that allowed?
Yes, right? You could
But
cancel them out, the twos.
not cancel, but like factor it out.
Yeah.
But when I factor it out, what happens? Actually, maybe I take a step back. So whatever, so this square factor here, this power goes to all these numbers here, and I have to do a big thing. So let's just do, if I put 2 out here and I pull it out, you guys see what I just did? Because there's a 2 here and a 2 here, and I can pull it in the front.
Ah, yeah.
To avoid ever doing this again, that's why I'm teaching you the rules, okay? So I'll never do this again if you don't want me to. But it's just to teach you the rule, to show you once. So now what happens? How do I get this 2 away? How do I pull it out outside? What do I have to do to it? I have to square it. The square here, the square here. To put it, move it away, I have to square it. So what's 2 square?
4.
So because of this whole deviations from the mean, square deviations from the mean, whatever value I want to know about changing, it's also going to go and get squared. It's going to affect it. So the variance operator also, what it does is it does the same thing. So this is actually going to be 2 squared, or 4 times var x. So the rule is, in general, I'm using these examples to motivate the rule, okay? So, oops. So the rule in general is that, I'm going to do that again. So in general, var of, I think I said B, I called it B, hold on, let me make sure. Yeah, I called it BX, or let's do it like that. A plus BX is equal to B squared var X. That's why. Because you end up squaring all the values. So if you multiply some number to it, you're going to square that number and put it in front. So what is var to X? So the rule is, if you multiply by a scalar, then the variance also gets multiplied by the square of the scalar. What happens to the standard deviation though? So I'm going to write that's my symbol. This is called a linear transformation because it looks like a line. I'm multiplying and I'm adding. It's doing the 2 things that you can possibly do. Multiply by something and add or subtract something. So I'm going to write it like this, standard deviation, or, okay, I know what I'm going to do. I'm going to write it like sigma, because that's standard deviation, right? Because this would be called, that's the variance. I think that's the best way to do it. What would the standard deviation be?
Square root.
All right, so I did this all because the only way I can show you this about the standard deviation is to talk about the variance first. So it's a very simple rule that the standard deviation of the new variable is just whatever you multiply to every value of X, you multiply to the standard deviation. When it comes to the variance, you have to square it because every value was squared to get there. But then when you get to the standard deviation, it's just multiplied. So now, knowing that rule, what is the answer for the new variance? I'll move it over here. Let's call it the new standard deviation, just makes it easier. I don't know, makes it easier for me. Thing is, I showed you the operators using the variance, so I'm just gonna say the sigma of 2x minus 1 is equal to sigma of 2x, like the whatever you did the subtraction doesn't matter. So what will it be? All that y. I'll make another note, shifting doesn't affect the variance. Let me check the chat if anyone answered my question. So the question was, so it's going to be 2 times sigma x. And what was sigma x given? You were given a standard deviation of 3.23. So you were given information that the mean of x was 1.3, $1.30, and the standard deviation of x was $3.23. And so what is the new standard deviation?
646.
So who's asking the question? It was Wilma?
Yeah,
with Maddie?
here.
Yeah, with Maddie. So you get it now with Maddie?
Yeah.
I'm sure we've confused like
More
a
or
lot
less,
of people, but you got it now, right?
yeah.
I'm happy one person got it. Yeah, because other people weren't thinking about this or didn't do that. It's actually, will Maddie tell them it's very easy now, right? It's not so bad. You just needed to know what you were supposed to use because there's lots of formulas there. But so that's what you're going to use.
Ya no entiendo. Ya me van a freír.
Yeah. So these are dollars. So
Aquí,
you're gonna put dollars on it.
hay unos que hablan inglés, pero yo no, yo con esa clase yo no, yo lo hago es conectarme por
Is somebody
conectarme.
talking? I
Somebody's
don't.
talking. I can hear you.
Yeah, I think so. I don't think that they know they have it.
I'll just mute them as best I can here.
I understood. Thank you for the in-depth explanation, because I know like where everything comes from, you know. So it was
Connect.
quite, yeah. 'Cause
Yeah,
I also,
it's
I don't-
confusing in my video because I just go line by line. It's better when you have an example. Right?
and I'm also thankful that this is recorded, like so that I can write the notes, because right now I'm just like observing,
Okay.
you know, and
So
taking
you
it in.
follow, Eddie Bell,
Yeah.
you followed? Okay.
Yeah. Thank
Okay,
you.
so I apologize for people who never saw this yet. And that's how it is, but But that's how it all connects, okay? So yeah, I encourage everyone to watch that again if you need to. So what we learned then, what we reviewed is the rules for mean and variances. This is actually the easy way. This is actually the easy way. Because if you had to actually, you know, it would be time consuming and it's not necessary to observe the whole thing. You can use these rules and you don't have to know the original distribution. That's the beauty here too. I don't need to know the shape. All I have to know is the mean and standard deviation of the original and be confident about it. And these rules apply. So, should I do another one like this or no? Let's do something else. And everybody else can just review these.
Mute or
Christina?
Professor, I posted,
I wasn't able to hear the last thing. I think you were cut off or on mute or something.
Oh, okay. I just said, do you want me to do another one like this? Or Christina, do you mean the whole last part? Or do you mean just that
No,
comment?
no. Just a few seconds back. I think you were
Okay.
cut off.
Okay, so I was just saying that, yeah, I think that it, in the notes, the way that I did it, I just read what line by line and I did not apply it. So it's better to apply it than to talk about the theory, but it's just that, this is a simpler method, as a little bit complicated that it looks. I'm trying to explain the origin of it with this example.
Professor, I have another one that cracked my brain. It was on quiz 6.3, the number 2.
Okay, let's see if I can do it.
and something I posted in the chat, Professor, you have the probability the quiz about but the one that is in paper. Number 10 and 11 is related to this one also.
Okay. Okay, I'm just looking at the question.
Sorry, I did wrong. It's problem number 14 and 15.
Okay. Okay, so here's the probability distribution. Again, it's discrete. If you select a candy at random, what is the probability that it will be fruit flavored? Oh, no, this is easier. Which ones are fruit, Wilmari?
Strawberry, orange,
Okay, so you
and
cherry,
cherry.
strawberry, orange. And unfortunately, my numbers got a little mixed up. So that's cherry, that's peanut butter, strawberry, orange. So what's the problem? You don't have K, right?
Yeah.
How will you find K? This is a fundamental, very basic problem. What is the probability? Sorry, this is called the sample space, right? And the sample space probabilities must sum to, how much should they make? Si se suman.
One.
One,
Like
supposed to be
62.
one.
100%, right? Yeah.
Oh,
So,
yeah.
so what is K? So it's algebra. Find K.
Mm-hmm.
So try and find K and then I'll show you the answer.
You need to equal to 1 and then resolve to K.
Let me stop this for a second. Hold on. I'm going to share just I'm going to share just that thing. Okay. So sum them to 1 and then it's going to help you find K.
Is it 0.38 or
Remember, there's two Ks.
So if it's just for fruits, need to be K plus 0.14 plus 0.21 equal to 1, right?
Okay, let me see if I can put both of these things on the screen. 1 second. Oh no, I won't do it like that. I'll just write it again. Okay, hold on, let me write it out. I feel hungry now. Just copying it and then I'll show you my screen. Okay, so I'm gonna take 0.21 plus, I'm gonna just put 2K plus 0.27 plus 0.14 makes 100% or 1. Then I sum all the value. I collect my terms. I put these all two together. What do you get? Did I make?
Professor, the question is not just for fruits. I believe it's just for fruits.
Yeah, but I need K first. So I use
right. Okay.
information to find K first, and then I get the fruits. It's 2 parts. Good question. So what do they sum? Collecting your terms, you have 2K, and what is your constant?
0.62.
Yep. Mhm.
And now collect the other constants together, and what do you get? 3.8. I think Christina said 3.8, or someone said. There you go. So K must be?
The 0.19.
0.9. Yep. 0.19.
19. And now you need to get the cherry, strawberry, and orange. There you go.
.67.
Yeah, 0.67. Woohoo!
Feels good. That's why I mean suffering, you appreciate after suffering, you appreciate the answer more.
Mm. Mm.
And notice I don't write too much. I just do it with the numbers. You know, I explain myself a little bit just to show you how I expect the answer. So I know what you're trying to do. But this is K is going to be 0.19. So you got, what did you get?
67.
Yep, 67.
Okay. Your final answer.
Good.
Well,
Thank
there's a
you.
lot of- Great. So Wilmati is good.
Yeah, thank you.
So let me tell you guys why you need to learn this and the other stuff, because on the final exam, I mentioned last class for the final test, there's going to be a section dedicated to these rules. Though this is just a probability rule. But let me show, I'm just reading the chat. Okay, good. So on the platform, so if you go to module 9, the last module, I've listed the distribución aproximada del examen final. And you see here for module 6 and 7, I said it's 20% of the final exam, and you can exclude hypergeometric and Poisson. Although I asked you questions in the quizzes, and I do ask you questions in Connect about it, but there's not too much there, right? 20%. But then here, that 20% is falling over here. The short answer that I require you to do is 6 points. And so that's 10% of the 20%. And that's going to come from the pages in modulo 6 and 7 that are about the rules. So you need to know the rules, or at least do repeat the problems there and know them well, because I'm going to ask you a similar problem for 10% of your grade. Okay, so you need to know those rules. So it's good you're asking me now, so people who haven't had a chance to understand or review that realize the importance, okay, of that. Questions about that?
Professor, and where the module I can find this document?
Okay, so back to
Module 8 or 9? Oh,
it's in 9 at the bottom.
module, okay.
Yeah, I know it's very, very far at the bottom. I mentioned it last class, but maybe some people missed that. But it's here. And then you also have a exam here to practice with the answers. Don't look at the answers till you finish. You should sit down quiet for 3 hours somewhere with no interruptions. Your materials, of course, but try and stay off the internet and try and finish this exam. And that way you'll be aware where you need to study, you know, where you're getting things wrong when you check the solutions, or even your discomfort. So before the last meeting, you should try this exam and we can talk about it. But the answers are already here. It has the same format as this one that you're going to get.
And Professor, look in the distribution. The exam will be 60 questions, right?
No,
Like
60%, 60 points.
oh, got it. Okay.
60 points. So 24 points from multiple choice.
Mhm.
Let me
No,
see.
yeah, I'm just looking down what's
30 points, which
24.
is half the exam. You get to pick 5
Mm.
questions from 7, but they're long, you know, I call them short answer, but they're kind of long. but you're solving problems and I'm grading your performance. It's not like the multiple choice where you have to pick one and I will have as evidence your choices. I actually will record, I will grade your performance, not just the answer. And then here as well in the short answer. And you'll have better idea of the format. Study that. So I apologize that one is not in Spanish. But I can make the final in Spanish if that helps. But the mock that I have, the mock exam, is the same format as this. Honestly, all I do for the Spanish is I put everything in Google Translate. If you guys don't like that, let me know. If you don't understand, let me know. And you can do the same. You can put it in Google Translate if you don't understand something. We have to be,
Professor. But poisson in the book is considered optional. We have to study poisson for the exam
it's
or
omitted.
not?
It's
Don't understand
it's
the question.
omitted. Omit means not on the final. It's not on the final.
Okay, all right, because
It's
it's
just-
optional, yeah.
It's
Okay.
just practice, and the point to teach you hypergeometric and Poisson is for you to know the difference, to learn that it's not binomial. That's the main point I want to make, is that you can see, that's not binomial. What is it? It's Poisson. I'm trying to put a label on things for you that you can know there's a difference. Hypergeometric sounds like binomial, but it's not. And these are very common distributions. I had a map once. It was like 100. There's many distributions, hundreds of well-studied and developed distributions that they're actually programmed into Excel. And I show that in the instructional videos in the classes. I show how to get the answer for the binomial out of Excel, but you can also get Poisson, hypergeometric, and some other distributions out of Excel. But in the old days, in the 70s and the 80s, and before computers, everybody had books and books of tables, and they use those to approximate values. But now we have Excel, we have computers, and we focus more on interpretation than the computation. You can get the computations very easily. Any questions about the format for the final and where you need to focus your time, right? So really, let me see again the platform. So we are on schedule. Today is the 30th. So you finished, and this week you should have studied module 7, which is really module 6, just topics on different kinds of distributions, the rules of probability, means and variances, and then and some Bayes. But Bayes also will not be on the exam. Did I say that? Let me see. Oh, I didn't say that. Omit. I think it's like I say omit. I didn't write it here. Bayes will not be on the final exam either. Bayes theorem. Sorry, Amaria. I didn't write it.
Thank you, because I was a little confused with that.
Yeah, don't worry, because Bayes is important. Again, it's important, like, that you know that that's there and it exists and it's interesting, but I don't expect you to be an expert.
Okay, thank you.
I didn't write it there, but I don't know. How didn't I write it there? Maybe I should fix that. I don't want to promise you I'm going to fix it. So write it down. Bayes theorem is not on the exam. It's just for practice. I'm being very specific what I want. Also in module 8, there's a topic called continuity correction factors. That's very interesting. Also some terminology you need to understand, because a lot of statistics before computers were widely available were completed making estimations of distributions, probabilities from distributions, and the term continuity correction factor is an improvement on the estimation. So I just use this example in binomial to make my point, but I don't need to test you on it. Okay. So this following week, you're going to focus on module 8, which is the last step before the most important module, module 9. The foundations for inference are in everything we've done since everything in the class. All of it has been leading to inference, which is module 9. But module 8, we're going to elaborate the binomial distribution, which is pretty basic, and the sampling distribution, the statistics of a sampling distribution and what that is, because we need that for inference. Let me go through the chat. People wrote a bunch of questions to me. I am going to,
Professor, I already sent you an email, but I just want to know the grades about the participation in class.
yeah, I said at the beginning, I'm gonna fix those. The next
Mm.
last 2 weeks have to go up, yeah. I haven't had a moment, I'm sorry.
Okay.
Yeah, but I have everything recorded, so I can review. That's Vanessa, right?
Yes,
Yeah, I'll get it up for you. I'm gonna reward you.
thank you.
Huh.
Hmm.
Okay, problem 14 and 15, Orlando, where are those?
Yes.
Where do I find it? In the homework or?
In the homework, they're labeled like prop 14 and prop
Okay, let's do that.
15.
So I'm just gonna go into the chat now. So put any questions you have in the chat. I'm gonna start at the top. There were some from last week. Did I get them done? There were some outstanding from last week. Don't be shy to put them.
The one you left the ones related to the boxes
Oh, did I leave that? Or you're gonna do it? It was in the videos.
no you did it just the final part was pending for us to do it by ourselves.
Oh, but did anybody have questions about it?
Myself.
You do, Orlando?
No.
You're okay,
I'm
okay.
okay with that.
Okay.
I'm only lost here when we go from the original mean and standard deviation to the
Oh, how was my
to the
explanation?
transformation.
Yeah, how was my
The explanation today was very good.
okay,
It helped me a lot.
okay. Yeah, it really requires explanation. It's not so clear. I agree. I don't know what I did there. I was just reading the notes, but it really is better with an explanation, with an example. Okay, so let me go to the homework. Oh, the homework will be in module 6.
Professor, I have a question. During the final exam, we need to write like a sentence, explain the results that we had, or we just put the numbers and that's it.
Okay, so for the final exam, I'll go back there for a moment. Let's go back there to the final exam. So, oops, I didn't mean to push that. So module 9, you can see this?
Yes.
And okay, so in the multiple choice, you have to put your evidence, but I'm only going to grade your answer. The evidence is just to defend you if you interpret something differently and you want points, and we can have a discussion about what you wrote. And so that's why we need the evidence there. And these ones, I will grade what you write down. So you have to learn how to systematically answer the questions, right? You have to learn what I want from you. And the same thing with this final answer here.
No, yeah, my question is more in terms of numbers or words, meaning we need to explain in words the number results or just the numbers.
You just need to answer the question, like I'll say, make a decision or tell them, just, yeah, you have to explain, you have to answer in words.
Okay.
Yeah, you'll have to answer in words. I won't say, oh, what is, how do you, what does it mean to have a sum of variables? I'm not going to say anything like that. I'm just going to have you solve problem quantitative, but answer final answers in words to explain what you got.
Okay. Thank you.
Yeah, nothing too theoretical. It's very stressful. And then because the exam is remote, you're just going to copy from your book and it doesn't mean anything really. So I prefer you guys to solve problems. It's much more applied, much more meaningful. Anyway, my opinion is my opinion. I have to modify the way I teach depending on the modality, right? Okay, so let's go back to what was I gonna do? I was looking at the homework.
Professor, is it gonna be the same thing as the first one where you open it? It is gonna be open for a couple of days before
Yeah.
we submit? Like we
Yeah,
get a
it
couple
was-
of tries?
Yeah, it was 3 days, right? Last time I did 3 days and a half or something. Yeah, it'll be the same.
Okay, thank you.
What day did I put the exam on? Was it the 5th? What did I put here?
I think it opened on a Saturday, the last one.
Oh, sorry, no. It's gonna be November. Yeah. Okay, yeah, sorry. You
Mm.
guys are ending early. The 4th. And let me confirm something. I'm pretty sure, because I said 2 hours there. I said it should be 2 hours. According to the calendar, I have to make sure I have enough time to mark it. Just stay there for a minute. I probably did check. I just gonna confirm because you never know. Okay, so yeah, it's gonna be due. So the 4th to the 5th, 5th to the 6th, 6th to the 7th. I have to mark it in one day. The grades are due on the 8th and the 9th. I don't know why they have 2 days, but hopefully that means the 9th. So I'll have a day at least to grade. So there's not gonna be any chance for any changes.
So, Professor, pardon if you already said this, like, what is the exact date that the exam will open?
It's there on the platform. It's the 4th of November.
Ah, my
At the
bad.
top. Yeah,
It's like right on my face, my bad.
yeah, it's right at the top.
And also you mentioned that it'll be like the last exam.
No, it's gonna
No?
have a different format, and it's
Yeah.
on module 9. Yeah,
No, I mean like
72
as like-
hours. Yeah,
yeah, so it will open for 2 days.
it was 3 days, right?
Oh, yeah, the last one was 3 days, yes.
Yeah.
Okay.
And we'll meet on we'll meet on the 4th, and then I'll open the exam at 1 p.m.
Okay, perfect. Thank you. And sorry for not seeing. Oh my God. I don't know what's wrong with me, but thank you.
It's okay. I fade out all the time. It's okay. Even when I'm talking, even I bore myself.
No, that's thank you so much.
Get distracted. Okay. And it's important information. So we have the recording, but it's easier if I answer here. Okay. So let's see. Going to homework. The homework is in module 6. I'm gonna go down to the homework. So we're good. We're on good schedule here because today was the 30. And then next week's gonna be, we have 2 weeks to finish module 8, but there's 2 parts to module 8. So this week focus on the binomial, and the next week you can focus on sampling distribution. Okay, spread out your time. It can be very confusing, but watch the video first and then attempt the problems for binomial, and then sampling distribution of a statistic will be the following week. And then we have 2 weeks for, why did I say 6 hours? Well, we have 3 weeks till the final working on inference. So we have perfect timing. And people who have fallen behind, do your best to catch up, because this is the chance to catch up. I spread out things very much. Okay, so where was I? Homework, Orlando. Homework here.
Yeah, I have a question because the next module is also 2 weeks, right? I'm not-
Yeah, so spread it out with binomial this week and then sampling distribution of a statistic next week. Don't wait. Don't wait till the end.
Okay, perfect.
Yeah, because the binomial is pretty straightforward. Just 1 minute. I have to deal with something here.
I have a question regarding the quizzes in Connect.
Yeah.
I have not been able to do the ones that were assigned last week. I'm planning on doing them today. Are they still available?
I can't remember. Are they still available? Everyone? I have to check.
It's just one available
Oh, just one,
until
yeah. Till
until
when
the
then?
next Tuesday.
Okay, till Tuesday, yeah. Yeah, it's okay if you miss 1 or 2 of the connects. Don't worry about that. But you should be able to still enter and see the questions even if you didn't do it. Is it true?
Yeah,
that-
I think the first one, that was what happened to me. It shows as study. It says study, so it's not graded, but you can still see like your results and use it as a little practice.
Yeah. Okay, so let's do number for Orlando. Sorry, I've already lost memory of which one we're doing. 8, 13, 12, 13, 14, 15.
14 or 15, yes.
14 and 15.
The 14 is in the videos, but it's so fast that I can follow.
It's too fast.
No, the way you jump from to the linear transformation.
Oh, okay. Role-playing games like Dungeons and Dragons use many different types of dice. Suppose that a 4-sided dice has faces 1, 2, 3, 4. The intelligence of a character is determined by rolling this dice twice and adding 1 to the sum of the spots. What is the average? Okay. Faces are equally likely and the 2 rolls are independent. So we need all that information. Why do we need all that information? So we can use the rules. Oh, right. Oh, because, okay, I need the independence for the variance, which I did not discuss. That's the one thing I didn't discuss yet. So 15, I did not discuss yet. So that'll be a good example. All right, you guys can do the mean. You do the mean and I will help you with the standard deviation, because what we're doing is basically x plus x, right? Rolling this dice and adding 1 to the sum. So you create a new variable. It's going to be x plus 1. Because x, do you follow that, Orlando? X is this
Yeah.
1, 2, 3, 4. I have to think this through. So you guys work on that one and I'll make sure I can get the right answer. So you need to find the mean of the variable to begin with. You don't have that, right?
Yes, the mean is 2.5.
Good. Okay, let me share what I've done here. So the original variable was had the outcomes 1, 2, 3, and 4, and each is equally likely. So if I want to know the average outcome, I mean, I just add them together and divide by 4 because they're equally likely. Otherwise, I have to do the weighted average. So that's how I get 2.5. I hope this works. And then I create a new variable. So let's make it the symbol then, mu. So we can write mu x equals 2.5. So now we created a new variable that says add the sums together of the same dice and add 1. So that's x plus 1 or 2x plus 1. So this looks more familiar to us now than from what we did just earlier. So then this, whatever you do to the values, you also do to the mean. So it's just like that. So now we plunk in, put in the mean. And what do you get? 6? How's that? You might not completely understand it, but you can calculate that.
Yeah, 6.
Is that the right answer?
Yes.
Okay. Does it make sense now?
Yep.
But I got the 6,
Good.
but I didn't go through any of that. I don't understand,
Well, yeah,
when-
what did you do? What did you do?
well, I multiplied each one by 2 and I added 1 and then I divided by 4.
No, but it's okay. Let me think about that. You took each one.
Uh-huh.
Say it again, say it again.
I multiplied by 2.
Okay.
So, okay, and then I added 1
Yeah,
to each
so
one.
what you did is you created the new distribution.
Right, but I didn't go through all of this.
No, but what you did was create the new distribution. You made that, so this is the new variable, the new distribution. I'm trying to do it an easier way, but you find that easier, it's fine. So you basically took you did what we did with the graphs, right? You added something and multiplied every value the same. So new distribution is just like 2 times the old one plus 1. So you did, this would be 3, this would be 5.
5, 7, and 9.
Yeah, so that's all you did. And you got the mean. You're just fine. I just did it to the mean. You did it to every value. I did the same thing. And then because they all have the same this is-
Probability.
yeah. That's what you did. That's your intuition. And that's the thing. Statistics is, it draws from intuition. Your intuition is good. I'm just going to do that to every value. That's just like that. So then I just find the mean. It's that you actually did the weighted average, but the weights are all the same. So you just added, you did the regular average. You added them together and divided by 4 because that's the regular average, and you got 6. That's what you did. You did it to every value, but we just did it to the mean. Okay? Feel better? You're doing the same thing. It's just that this is not feasible if you have thousands of values. That was Christina, right? So we need a rule, because this is not, you can't sit there writing 1,000 values and figuring it all out. We need a pattern. That's why we did it like that. And see, it looks feasible when you have 4. But we need a pattern in general if we have a continuous distribution, even with infinite values. What are we going to do? Yeah, tell me.
I want to know how to enter that in the calculator.
This
But
or the weighted average?
no, you're saying that if there's many numbers. Okay, I disregard. I understand.
You understand? Yeah. If there's many values, you don't want to do it your way. You want to just use it my way. I'm just doing the general case because you don't want to do this forever. You're just going to do it to one thing, the mean, because it gets treated like all the other values.
Okay.
Okay. All right. So let's see about the standard deviation. So this is our new variable. Let's talk about the standard deviation. What did we learn about the standard deviation? We learned that the standard deviation of the new variable is just
Where?
So we're going to write a plus bx, so that we can do a linear transformation, and it equals, something's wrong, right? Because this is not a linear transformation, is it? Oh yeah, it is a linear transformation. It is, because we have, let's put in the numbers. This is going to be 1 plus 2x, right? A, if we go with this is the a, the adding the 1, and this is the b multiplying by 2. Are you with me? So what is the rule we just derived earlier? That we don't care about the 1, it just becomes this, and it just becomes 2. So however you multiplied it, that's the variance is only affected by the multiple. It's not affected by the 1. It's not affected by the shifts. And so too, the standard deviation is not affected. I'm writing it in terms of standard deviation because I think it's confusing to write as the variance, but I can do it with the variance too. So the variance of y, or the v of y, I'll write it as variance because that's what I do a lot, is equal to the variance of x, or 2x plus 1, which is the variance of just 2x. And what did we also say before? The 1 disappears, right? Because the shift doesn't matter, it disappears. So what happens with the 2 in front?
Multiply by 2.
It gets squared, not multiplied by 2, it's squared. Because so if it was 4, it would be 16.
Right, but I said that it would be squared, and now it's 2x. That 2x doesn't.
It just
Ah.
because it's a 2, it looks like 2 times 2, but it's,
Ah.
if it was a 4, it would be 4 square. It's 2 square. The
Okay.
square is the important part, not the 2, not the base.
Right, okay.
Okay, so then it's 4 and then variance of x. Sometimes I have curly brackets, sometimes I have. All right, so what was the standard deviation of x? What was the variance of x? Do we have the standard deviation? So how will you find the standard deviation from these numbers?
You have the square root.
You put it in your calculator, like usual. Oh yeah, down here is square root, but don't worry about that right now. What is the standard deviation of the original variable? The mean was just add them together and divide by 4. This is the standard deviation. Put it in your calculator. Don't forget the tool of your calculator. You put them in to get me the standard deviation. So let me do that for you too. So I put them in with data. Oh, there's something there. I need to clear that out and start entering the values. 1, enter frequency 1. 2, enter frequency 2. 3, enter frequency 3, and 4, enter frequency 4, and then second stat, and I get the number of values. That's the mean that we already had, and there's a standard deviation. So don't forget that. Back to what we learned in the 3rd module. You can just round it. And so the answer is and I'm going back to where I left off, 2 times the standard deviation, so 2 times 1.29. Let me check the chat. Is it 2.58, Orlando?
The answer is yeah, but the answer in the exam in the exercise is 2.5, 2.2, right? Sorry.
Sorry, what do you mean?
No, that when we calculate it is 2.58, but when you look at the answers of the homework, it says that is letter D,
Okay, let's see.
that is 2.2.
2.2. 2.2. And how did I do it in the explanation?
That one you didn't do it. The problem number 15.
Okay, how spread
You
out
did
of
the
the
14.
that's measured by the 2.2. Oh, well, 2.2. That still wouldn't work. Standard deviation. I'm pretty sure I did it right just now. Are you sure? Let me check. 15.
Yeah, I'm looking at the test
Yeah.
page.
Yeah. 2 point. I wonder if I did anything wrong here. Let me check. Data 1, 2, 3, 4, 5. See if I can do it again. .29 times 2. 158. Well, I think that is an E. I think it's 2.58. Does anybody have a question so far? I'm gonna have to change that if I really believe that. I'm pretty sure it is. Unless if I round to 1.3, that's even worse, right? No. 0.2. Yeah, that's pretty much how you do it. It's whatever. It's probably wrong. Yeah, I don't know another way to do that. So the point is that if you had this question on the test and you got 2.58, I would give you the right answer. I would give you the points, I mean, that would be the right answer. So if I did it with everybody with me so far, I'm confident about this result because I got the standard deviation, just like I got the mean where they were equally likely. That's the mean, that's the standard deviation. The only thing I can think of maybe is that you use this as you get the population standard deviation. Let's do that because that'll be smaller, right? Let's do that because if these are the only possibilities and then I can't use the sample. So going back to my calculator, sorry, I'm being iffy about this. I haven't seen this question in a long time and I'm trying to think of what the intention was. So let me go back to the calculator. That will make sense to me now, if that's the case. So let's see, what was the population standard deviation? There it is, Orlando.
Okay.
Okay, so we're not going to use the
0.1.
sample because this is a distribution. And now we all learned something that this is a way we can use the population standard deviation. Finally, we get to use it. So this is 1.1. Just take the first decimal, or you can even take the second one and it'll still work. So it's not S, it's really sigma. Okay, and why is it the population? Because I have a distribution. When I have a distribution, it's the population. And let me make that shrink that and put that here. And I'm going to make it bigger. Any questions about what I just did? Did I just blow your minds? We get to use that. So it's smaller. Oh no. So I'm going to fix this and it's going to work beautifully. 2 times 1.12 is now 2.24, which is fine. It's the best answer, D. Because if you rounded it, it would be 2.2. So this is a population. This is the probability distribution. This will be the population. So let's say this question was on a test and you made the mistake that I made and you got the wrong answer. Then you would say, I would give you, so if it was in one of the choice problems, you know, I'm going to give you some choice. Then you know, out of this, I would give you like, if it's out of 5 points, I would give you 4 or even 4.5 points. Like you're not going to fail because of that. Okay. So, if you do have confusion about why you had a question wrong, because I will grade, you will get the grades of your test. You can contact me before I submit the grades to know what you did wrong and to defend yourself. Okay. Okay, so let's see the variance answer. If I did it the variance way, once I'm done, what is the variance? How would I have to get the same answer, correct? So this is 4, and the variance of x is going to be, so if this is the standard deviation, then the variance is equal to 1.12 squared. Not to complicate, not to confuse you. I just wanted to show you, I want to encourage you just to do it this way with the standard deviation. So I'm going to show you this one gives you the same answer. So what's 1.12 squared?
One point 20.
25. 1.25.
2544, yeah.
Yeah.
1.25. Yeah, we can go with 1.25. So this is
5.0.
and then 1.25, and then you get, what do you get?
5.
Okay, 5.
Yeah, 5.0176.
If I multiply by 4,
Yep.
it's just 5, no?
Yeah.
Okay, and then, okay, so then, and then what? The question was, what is the standard deviation? Sorry. What's the square root of 5? 225, I think. Two, 2, 4. So it's still the same answer. Hope I didn't lose people. I'm just showing you that you can do it this way, or you can do it this way. You get the same answer. Still, it's still D. So Orlando, we did 2 problems for you.
Thank you very much. Thank you.
Yes. Do you feel better? So the big thing was we both learned that we have to use population on that one. And that was a big tip. That's not going to happen very often. But just to see, just to say, if you get a distribution, that you have to treat it like it's the population, not the sample. Yeah, I'm looking for more questions. Okay. Page 44, module 6. Vanessa, you want me to look at that? Oh, and Carolina asked me, module 6 and 7 assignment. I have doubts. Okay, we can look at that first, Carolina. And Orlando, did you want me to do 10, 11, 15 still?
No, no.
Oh, you're good?
Yeah, I'm good. That was my mistake. I marked them and I thought that I was providing the right numbers.
Okay, so let me see. Assignment. I guess that's the one we were working on last class. But question 6 and 7. Okay, let me go back. While you're copying from there, I'm gonna go look at the notes, page 44.
Okay, I'd like to share something. I don't know if everybody knows, and I was the only one that didn't know, but if you're using your computer and you want to snip this quickly while she's writing, you go Windows Shift and S, and you can snip it and put it in a Word document.
Thank you. That's Christina or Vanessa?
Yeah.
Christina.
Christina.
I'm learning your voices because I can't always see you. I'm learning your voices. Okay, so thank you. Helpful. 44. Oh, 44. So that's okay, let's talk about that. No, wait, I'm getting lost. Okay, no, wait, we're in module. Who was asking me page 44? Page 44. Where did I see that? Modules, that was Vanessa. Okay, module 6. Okay, Vanessa, are you there? I want to ask you if you can do this now, because maybe you can do this now. The answers are all there, but let's talk about it together. I don't know, Vanessa stepped away. I'll wait for her to come back. Someone remind me. Okay, let's because basically that's what we talked about. So let me show that for a minute. I'm going to stop sharing that and share this. So this is page 44, module 6. And you see, I'm going to do the variance thing, which I expect you to know how to do, but if you have a choice, stick with the standard deviation. But it's pretty easy when it's like this, and you just have to show the pattern. So for the first one, the variance of AX plus BY. Let me see, if I can cover, I'm gonna cover the answers so you can't see the answers and just show the questions. Let me just show, oop, I lost it. Let me close this. Close this. I start over. Okay, back to. Okay, I want to cover the answers. No, can't do it now. Okay, I'll do it like this. So what's the answer to the first one? If you take two variables and you add them. So this I didn't do yet. This is important because I taught you the linear transformation and I taught you the sum and difference of variables, but I didn't teach you the variance of the sum of variables. Okay, so this is like the last thing you have to learn in these notes. So what's the variance of this? Let's talk about that. Is it just going to be? Okay, let me transfer to my iPad and talk about it. Okay, so what's the variance of this? Somebody tell me. I don't know if you want to do it in the chat or speak out. So what we learned so far was that I'm gonna try and make this less confusing as possible. So I'm just gonna write, I'm gonna put my hand steady. And we learned that if you take two variables, right? That's what we learned. And then we also could add those two together and say, okay, what would that be? Just follow the pattern. So we learned about, this is called the linear transformation. We get, so whatever we do to X, we do to the mean. If we add two variables and they have their own mean, then we just sum the means to find the average of the two variables. And it's the same for the difference. If I subtracted the two variables, then this would just be their subtraction. And it's not a new rule. It's the same pattern. And then what about this one? Now I'm putting those two things together, the sum and the scalar multiple. What would it be? Orlando. I know you can do it, so I'm asking.
Sorry, Professor, I got lost because I lost connection. I
Oh, okay. It's okay.
wasn't paying attention,
So the
trying to.
okay, are you back on?
Yeah,
Stable? Okay, so the question was, we learned about the linear transformation. Whatever we do to X, we do to the mean. We learned about the sum of two variables. The mean of the sum is the sum of the means. The mean of the difference is the difference of the means. Now I'm going to put the two together. What if I have a scalar in front of X and I sum to scalar in front of Y? What do you think? What would be the pattern? Just kind of guess if you don't know.
Professor, this is the 44. I'm so sorry. I was struggling with my computer.
Oh, okay. I'm getting there. I'm getting there. I'm just doing some backup. I was kind of
Oh,
waiting.
okay. Good. Okay. Thank you.
So Vanessa, what I said was, we know this rule. Whatever we do to the X, we do to the mean. We learned this rule. If we sum two variables, the mean of the sum is the sum of the means. So we did that, right? Are you okay with those two, Vanessa?
Yes.
Now we're going to combine them. We're going to do sum with a scalar in front. So what do you think? What is the pattern? What would the mean be? Just, I don't expect the right answer, but you could probably do it.
The mean will be the sum of
The sum of the mean.
hold on.
So it'll be the sum of the means, but something's missing. What happens to the A and the B?
Yeah, A and B.
So I just
That is-
copy, right? I just copy. It's just whatever I do to the variables, the sum is the sum of their means, but I have to do the A and the B in front.
Mhm.
Okay, so it's same pattern. And this, so we did all of this already.
So will be square root of A plus
Wait a second,
B.
wait a second. Just wait a second. You're doing the var already?
No, not yet.
Okay, okay. So what I have to do, so we also learned the variance. So what did we learn about the variance? We learned the variance of a linear transformation.
Mhm.
What did we learn about it?
That is regression line, right?
Yeah, that's like a regression line now. It's like, but we call it a linear transformation. It looks like a line
Mhm.
because we're multiplying and adding something to it. But what about the variance of this new variable? What would the variance of the new variable be? The shift doesn't matter. And it's just going to be v of bx. And what happens to the b?
You have to
As
square
to
it.
the front.
It's
You have to
four
bring
four times,
one
right?
and you square it, right? That's what we do.
Okay.
Okay, and then, so now I'm gonna put in front of, what if I put now,
The A.
yeah,
Oh no, yeah.
the X, now I'm gonna do this. So that was the last step. So this is what we learned so far today. I didn't do this.
Mhm.
I didn't do this. So let's do this. What is this? This is the variance of the sum of two variables. I didn't do that yet. I just did this thing with a constant and like a shift factor and a multiple here that can make it flat or it can make it narrow. But now I'm going to put two variables together and get the variance. So the question I have for you, is the answer going to be, oh, see, sometimes I use var and sometimes v. I hope that doesn't confuse anyone.
Is
Is this the answer?
yes. And if it's a standard deviation, is supposed to be the square root, right?
Exactly. So we'll do that in a
Mm.
second. Let's deal with this first, and then we're going to do the standard deviation.
Alright.
Okay, so this is only true if what? So Vanessa's partly right. I'm going to be like a fact checker. She's partly right.
A little bit. Okay, so this is true if it's
If what? What? Who was able to get this far in the notes?
if it's a sample.
Nope.
I'm lost.
But something, I know it's okay, but anybody else know? This is true. It looks like the pattern, but something has to be true.
I know.
Tell me. You don't know? If nobody knows, I'm going to tell
Do you
you.
have the answer, Christina?
It's in the notes if you guys want to look.
I'm not sure if they are mutually exclusive.
Not mutually exclusive, but something about X and Y.
Independent then.
Process of elimination. Right. Are independent.
Mm.
In other words, there's no correlation between X and Y.
There's no influence.
They don't affect each other.
Mhm.
So let's talk about covariance, because maybe we need a recap about covariance a little bit. What is the covariance?
If both effects are affects by the same result.
Well, the independence was where if I know one, if I know one of them, the probability of the other one doesn't change.
Right.
Another way that we're going to speak about that is that there's no covariance between them. So in other words, yeah. So if I know, so remember this, where does this come from? When did we talk about this?
About covariance?
Yeah, when did we talk about covariance? We talked about covariance, recall, R, right? What was the R?
Oh, the correlation.
Yeah. Remember we had the discussion?
Mm-hmm.
This is
Mhm.
for
Yes.
samples. This is for samples, but for populations, it's also true. You're not gonna like me. But that's what it looks like. So in populations, we have different symbols for populations. Remember, for samples, we have the sample statistic, the mean, but for the population, we use a Greek letter.
Mm-hmm. Yeah, it's the same. You're looking for the correlation between the variables, meaning what is the probably that if you took, and the first example, if you took one, I don't know, it's a quarter or something. If you took a quarter and you flip like a coin, the probability that happen ahead or back or something like that. So it's the same, like the probability of X didn't affect probability of J.
Right, exactly. Like the probability distribution of X is
Mm-hmm.
not affected if you know, so in terms of flipping, the first flip, we can call it X1, and the second flip X2, it doesn't change the
It's always
distribution,
will be
it stays
X,
the same.
yeah,
Exactly, so they don't impact.
because it's the same event.
So now, so when students get confused, sometimes it's because I'm talking about old stuff. You're not allowed to forget anything. I should be able to pick anything from the past, okay, and
Mhm.
talk about it. This seems to be recording me here. That's not good. Hold on.
Yeah, it's the same because you're looking for the correlation between the probability of X and J. And basically it's the same, like correlation.
Okay, so but the point I was making is the symbols. So
Right.
R is the sample, but we use rho, the Greek letter R, for the population correlation.
Mhm.
I write covariance SX for samples, but I use this symbol sigma XY for covariance in the population, because what we're talking about here are probability distributions now, not just sample results, not just empirical results. We're actually using like the distributions. Okay, so you guys have to get comfortable with these symbols.
Mhm.
And then and it's good that we did that example, thank you Orlando, where I got to reintroduce the standard deviation of the population. So these symbols are the, what are the analogous, right? They're analogous. So, okay, so where am I going with this? So only if X and Y are independent, in other words, they're covariance, there's no covariance between them. There's no correlation also between them. This is true. So that's nice. So like I told you last class, statistics, the theory is simplified with this assumption of independence, but that's not reality, right? So we need to know when we have independent variables and when we don't. In this case, if they are independent, this would be the variance. But what are we going to do if they're not independent? We have to have another formula. So what's the other formula? So in general,
if you're not independent, you cannot sum, right?
you can sum, but there's a correction because you have to account for the covariance of them because they're going to interact.
Correct. So you need to divide it or multiply.
I'm going to show you the rule. So the rule is I'm almost there. So that's the same, but then there's something we subtract. We're going to subtract 2
Covariance.
AB covariance of X.
Oh, because you're looking just for Y, right?
X and Y. No, I'm looking for both. I'm sorry, I wrote it messy here. Let me fix that. This is X. This is X. What am I doing? This is X and Y. There. So this is what it looks like if that you don't know. If you don't know about the covariance or the covariance, there is a covariance. It's not just 0. there has to be this. You have to account for it's a plus. It's a plus. Hold on.
So this last rule will be
You have to
if you
add.
know the value.
But
Well,
it's
if,
in general. I have to plus, sorry. I have to plus, not minus. It might
yeah,
be.
no, but if it's if you know the value of the cup, or if you don't know the value of the cup.
No, it's true if in general, if you don't know anything. If you know it, you can put it there. If you know it's 0, then it falls away and use this one. It'd just be 0. If this is 0, the whole thing will be 0. Okay, so this is the relationship between two variables, some with a scalar in front. This you have to know that there's this extra term because you have to account for the covariance. So the example that I give is if you're holding these in a portfolio, let's say these are 2 securities, and there's a correlation between them. If there's a correlation between them, it adds variance or volatility to your portfolio in the amount of whatever the covariance is. Now, if the covariance is negative, the overall variance will go down, which you like because variance means volatility, right? It means it's uncertainty, more unknowns, and you prefer to be more certain. So it's often the case that people will hold securities that are negatively correlated. So for instance, like if they're holding 2 securities, maybe they invest in a company or airlines. Okay, so airlines are used a lot during the holidays and the winter holidays and Thanksgiving holidays. So airlines do well. Let's say airlines did well in that season, in the winter season, but construction does better in the summer season. Not necessarily in Puerto Rico because the weather's the same, but in North America or in northern countries. Okay, so stock returns could be negatively correlated for tourism or airlines and construction. So that would have a negative correlation, and you might want to hold those 2 types of securities together, because what will that do? That will lower the overall variance or volatility of your security. And I have an example. I have example about holding securities together in the notes as well. Where is that example? Where did I put that? I do that. That's on page 43. So it's just examples. Again, you don't have to be an expert. It's just examples to motivate the question. Let me make sure you're not seeing my screen. So on page, where did I put it? No, it's here. Maybe it's not here.
Three.
Oh, I think I put it on the platform.
Page 5.
Okay, so let's go to the platform. I'll show you my problem on the platform. So practice, lightning, Excel spreadsheet. Oh, exercise 6. That didn't work. It didn't open. Desktop. Downloads. Hold on. So you don't have exercise 6? I see it in the spreadsheet, but let's see where it went. Exercise. Where's exercise 6, Orlando? I guess it's not here. Let me hold on, let me see if I add it.
I think it's okay. It's Under Unit 4, problem Excel 1, and then inside it says exercise 6. Talks about stocks. I
Yeah,
know
that's
that,
the one. That's the example I want you to try to.
but
Exercise. Okay. What page did you say, Christina?
you were on the right one.
Yeah, the Excel, but you need the question. Oh, maybe I didn't put the question. I just put the Excel. Let me see. Okay, it's just stocks. Yeah, I think you need a little bit more of an explanation, but that's basically it. Okay, so let me show this so I can just make sense of it. Let me show you. Okay, so this is my example here with two stocks. And so this one, notice, can you guys see the Excel sheet?
Yes.
And I also did it with probabilities, nice and confusing. So when this one, so these numbers are bigger than the other numbers. The most likely is this outcome. Yeah, so there's some covariance. So I calculated everything with the tables just to remind you that you should also be able to do this with the weighted covariance. Okay, so you get to practice with the weight. And I put all the formulas in here. Did I? No, I did it step by step. I did it step by step. But you should also be able to get these numbers out of Excel. Maybe not. There must be a weighted variance in here and weighted standard deviation. So you guys can check it out. But I give you this table so you could do this manually and calculate the mean. So this is called the weighted mean, the weighted variance. And notice that there's no n-1, right? Because this represents the distribution. So there's no n-1 here. It's just the weighted standard deviation. The symbol should actually be sigma x because it represents the population. And then I got the weighted mean, the weighted variance, and weighted standard deviation for y. And then I combine them, and I get their covariance. And what do you see here? The covariance is negative, but it's close to 0. It's not that big. So when you combine these securities, what will be your, so if we did this, if we use this as an example, and you combine X and Y in a portfolio, so all these calculations just to get this number, which is the covariance, to show that there's a negative covariance between them. Obviously, if there's a negative covariance, there's a negative correlation. So if you put these together, if you put these securities together, showing you, the formula that I showed you, you would actually, in your portfolio, have less volatility than if than if you just, like adding them, if they were independent. In other words, you would have, and there was no covariance, there wasn't that extra term, you would have more volatility holding them together than if they are like this, with a negative covariance. So, this is just an example to show you the calculations for the covariance, to remind you of those calculations if you need them. But essentially, you don't have to do all these calculations. You can just use the rules. So I want you to learn the rules, because the rules will save you a lot of time if you were to do this if I was to say, okay, so this is X, this is Y, what about AX? What about BY? And I put them together and I need to find their new covariance, their new variance, their new mean, like all of those calculations. I don't have to do all of that for a new distribution. I just use the rules. So can I go back to the rules? So I just wanted to just show you this example and all the calculations that you can practice to know, to confirm that you know what to do, or at least that you know where this document is if you ever have to calculate the weighted mean and standard deviation of a variable and their combination, putting them together. So you would use this information and it would go into what we're doing right now.
Professor, just to be sure, the exercise is the one in the page 47?
No,
No,
what 47? No, oh, is it? Is it? Maybe it is. I don't
I
know.
think so.
Okay, let me see. Sorry, these are all exercises and I don't always look at the exercises. These are all for you to practice. So let me go back and see if those are the same numbers. So you have them. So you have the formulas all there for yourself. So if I go to the notes and I look again back down to the bottom. Are these the same? Yeah, I guess those are the same. Yeah, so I derived everything from problem 6. Okay, I see. Question D. So I have the table there to help you. But you should be able to repeat this with different numbers, okay?
What page is that?
Like she said, 47. It's the last
47.
page.
Okay.
Yeah, because I was trying to figure out because I had another pair of exercises, but I think I opted to just give you this one. I had another one as well. I deleted it. Okay, so you guys can repeat that one. Okay, let's go back to what we were doing, because these are putting numbers in, but and combining these assets in a portfolio. And you can take advantage because the correlation was a negative. Is there an advantage to holding the portfolio rather than either stock A or 2 alone? Yes, because you have a negative correlation. And look what I do. I do all of this. So this is the action of combining what I'm going to do now with just symbols, the returns to asset 1 and asset 2. And this is the square, 0.25 times the variance of R1. And this is the square of 0.75 times the variance of asset 2. And then this is 2AB, and the covariance term that's negative, which is just a slight negative, but it's better than if these were independent. It's still lower. It lowers the volatility, the risk, or the variance. the uncertainty. Those are all the same word. All right, so there's a video then, the video explanation of this last part of the notes. I show you how I can do this for even more than 2 variables, because in a portfolio of stock, people hold more than 2 variables. They might hold, or stocks, they might hold 20 stocks. They might hold, okay, or even in an asset that's made up of many stocks, like a fund or mutual fund of stocks. It has many stocks in it. And so they use these principles, right? These are the statistics around figuring out what can we expect based on return data, based on what people made in the past. So, or predictive models. So there's 2 types of data. There's the data where you use past information, and then there's the ones that use all kinds of economic information to create a model. And that's what we're doing. We have like this probability distribution where we calculated the variances and the covariances and estimate the variance of the combined assets. And we can do this for more than just 2. So I'm going to stop here because I'm hitting a 11:30, and tell you, watch the video where I combine more than 2 assets, and I show how the pattern expands. And then next week, if you have any questions about it, please let me know. But essentially, you should be able to answer all these questions, because one of these is going to be on your final exam. Okay, so these are just for 2, and here's an example. I did it for 3, and you'll notice for 3, this is repeated for Y, this is repeated for Z, and then notice I have 2 times AB, what I did over here, but I do it for each pair. I do it for XY, I do it for YZ, and XZ. So review the video where I explain that at the very, very end of, let me show you where I explain that. If you had any doubts, it's going to be over here. I have this very long, I have 20 minutes where I explain the last bit of the notes. And I'll tell you the spot in the video. Sorry for the ad. Because even though I tell you to set up your browser to open in Brave browser, I stopped doing that because it was opening up everything in Brave browser and driving me crazy. Okay, so here in the video, I'm talking about this explanation. There you go. So it's like the last 5 minutes, which isn't bad. Okay, this is it here. Like at around 17 minutes, I start talking about the last bit of the formula. So in other words, I've taught you all these formulas. This is the one I'm going to leave you to review. And you're going to let me know if you're confused. Okay, so it's like at about 17 minutes. And all this symbol means here is that we're going to consider all pairs of however many variables we have. And I explain what I'm talking about here. Okay. And then you'll see the pattern. So statistics is about means or expected values and relative measures. And essentially, once you get the pattern of those measures, and you'll be able to follow along just fine. Okay, so I'm just going to teach you the pattern of doing it. And the artistic students will have no problem. The mathematical students will have no problems, and we're all good. If you're both, all the more power to you. Okay. So review that, keep me posted, and then get into binomial. Spend this week focused on binomial. And if you have questions still about this, you can ask me next week. Okay, so have a wonderful weekend. Did I answer everybody's questions? If not, you can email me. We can either meet, or I think I did answer everybody's questions, which is good, which I'm happy about.
Professor, I had 2 other questions.
Carolina, I skipped your questions. Okay, Carolina, you can
Yeah.
stay on. I can stop the recording, or if you don't mind, I can keep it recording, and I can do them, but the rest of you guys can go if you have to go. So I'll just keep recording unless you mind, Carolina. So let me go back to the chat. It's in the chat.
Yeah.
Module 6 and 7 assignments. I have doubts. Exercise 6 and 7. Well, I was just doing exercise 6 assignment. Oh, the assignment. Okay, yeah. Was that with the box? Was that with the shapes? The shapes?
Yeah.
Okay,
One
yeah,
of them.
I can do that. Sorry, I know I mentioned it and then I got onto something else.
No worries.
It's here. Oh, no, that's 5. Oh, maybe not. 6 and 7 exercise. So it's in the quiz. Is it on the 29, page 29?
Let me check. It was in the module 6 and 7 assignments.
Well, what page? Oh, online?
Yeah.
The ones online? Tarea?
And it was in module 7, and it was named module 6 and 7. It was in the next module.
Okay. In the tarea.
Yep.
Module 6 and 7. Okay.
You can go to the solutions, and we can maybe save some time there.
Okay. So you have a random variable with a base. So this is just like the one that was in the assignment.
Yeah, I was trying it, and I'm not sure why are we looking for the area of the triangle? The area of the rectangle afterwards, and how did we get to the 180?
Yeah. I think it's a bad translation now. Hold on, because that's confusing. I think that was the answer to a different question, this part. Hold on. Why is it doing this to me? So bad. Okay, let me just do it because I don't know what happened there. In the because I had these translated for me and there might just be an error there. Okay, so I have to use the so area is equal to 1/2 times base times height. Area has to be 1. The base is 1. So the height is 2. And this is in the middle, right? Everything okay so far?
Yep.
And then, so we have a triangle and we have a rectangle. Correct? So we need to find the total area. We need to find this and this. One is a rectangle, one is a triangle. Are you okay with that?
Yeah.
There's something here that's like missing. Okay. I honestly don't know how we're gonna get there. This is my only issue. I didn't give you information on that. But I could get all of this 2 times 0.25, and then I have to take off half of this because this is, but I just don't know how you would know that. So I'm troubled because it's like I don't give you enough information, but maybe this was an old assignment and I might have told the students what's above here. Did I say anything? No. You could probably find it online though.
the base would be 0.75 minus 0.5, which would be 0.25.
Yeah,
And
that's okay, but then you don't know, like, the whole thing is 2, so you could go up to here and do 2 times 0.25 and get the whole thing, and then, but how would you know where to cut it?
in half.
Well, how would you know where you are?
Oh, okay.
That's the only thing. I wouldn't know. I don't know how I know that. So anyway, don't worry. I'm not going to ask you this question, Catalina, but there's some missing information. How would I know that? Because if you knew, so what is an isosceles triangle? If I look it up, isosceles triangle. If I look it up, it has, the area is base times height divided by 2. Is that it? Is there something else to know? That's interesting. They're all the same length. Okay, both. The name derives the Greek. What is the rule? The rule for isosceles triangle is that the triangle must have 2 sides of equal length. Anyway, don't worry, Catalina. I'm not going to ask you anything unless I gave you a bit of information to know where this hits. But basically, yeah, I don't know. I must have given information, or there must be something missing here. Let me see the question. Because I'm looking at the solution, but what did I say in the question? Maybe I gave the extra information. 6 and 7. Nope.
1.
Es la base, donde B es la base. No. Okay, so just don't, I'll think about it, but I don't know how I know where it intersects unless this intersects evenly. So like let's see if that's how it works. So let's say this was, let me draw it a little bit different. Let's say 0.75 is perfectly in the middle, which makes sense, and that's a bad drawing. So let's say 0.75 is here, and that's 0.25, and then this hits exactly in the middle. And then if that hits exactly in the middle, and this is the middle, and this whole thing is 2, wait. Let me erase that. So if this whole height is 2, and we assume that this is 1, because it's half of 2. I have to draw this whole thing again because I made a mess. Okay, let me do it again. So I'm going to draw it again. I'm going to say these two are the same. The basic point, Catalina, is I would have to give you more information so that I could have to give you the drawing or something. So if this is 0 to 1 and this is half, and then this is evenly 0.75, and then let's say that this is exactly half, somehow I'd have to tell you that. And then this is, we know because of this is going to be 2. So the whole thing is 2. And let's say this is exactly half, so it's going to be at 1. So now do you know how to do it?
Okay.
We assume this is exactly in half. Like I don't think I gave you enough information, but maybe you can find about the isosceles triangle. So then this is 0.25. And so you have 2, so 2 times 0.25 is equal to 0.5. But then you have to take off this extra bit that's not part of it. Doesn't give you 1/8. So I don't know. There's some missing information. So then you would take off And so what is that? That's half of half. But I don't know if that's true. Because if the whole thing is 0.5 and this cuts it evenly, this is 0.25. And then this is 0.25 divided by 2, and this is 0.25 divided by 2. So, but I don't think that's the answer because it says 1/8. So I don't know. Don't worry about that question. I'll have to look at that.
No problem. Thank you.
I'm sorry for the confusion. Is that the only one?
I had another one, but I'm gonna try to do it again, and then if I still can make it, I will
Email me.
pass it.
Email me, yeah.
Okay, no problem.
Sorry
Thank
for
you.
the trouble with that one. It looks like something's missing.
Okay, no
Okay.
problem.
Okay. So have a good weekend.
Thank you.
Thank you. Keep me posted.
Thank you.
Any
Thank
questions
you.
don't make sense?
Thank you.
Bye.
Bye.
Thank you, Carolina, for the question.